Okay, so get this. We are going deep, deep, deep today on something pretty incredible.
Yeah, you could say that.
A galactic collision.
Oh, wow.
But hold on, because it's even cooler than that.
Yeah,
It's happening in Stephan's Quintet, which I know you've heard of.
Sure.
5 galaxies, right?
Yeah.
Known about for, what, like 150 years? Something like that?
Yeah, about that, yeah.
But here's the thing. We're just now, like right now, getting the best view ever of this crazy event thanks to some new research and telescopes.
Yeah, no, it's really amazing what we're learning about this collision in particular.
So tell me a little bit about what's actually going on there.
So, there's a galaxy. It's called NGC 738-B, and it's basically crashing the party.
Crashing the party.
Yeah, it's like this intruder galaxy just barreling through Stephan's Quintet.
Farrah, how fast are we talking?
So get this, 2 million miles per hour.
2 million miles per hour.
Yeah.
Okay, I gotta try to wrap my head around that.
Yeah, pretty hard.
That's like going from New York all the way to LA, like in under 2 minutes.
Yeah, something like that.
Okay, officially mind blown.
Yeah.
But, when I hear galactic collision, I think like, boom, instant explosion.
Right.
Huge, massive.
Yeah.
Is that what's happening in Stephan's Quintet?
Not really.
Oh, okay.
It's more like imagine a slow motion dance
Okay.
on like a cosmic scale.
Okay.
It's happening over millions of years.
Millions of years.
Yeah, and because galaxies are mostly empty space, the stars rarely collide directly.
Yeah. Okay.
So it's not like, stars smashing into each other constantly.
Yeah.
It's more about gravity in shockwaves.
Shockwaves. Okay.
Yeah, from the gas clouds.
Oh, okay.
So the gas clouds smash into each other,
Gotcha.
and that's where we get the fireworks.
So the shockwaves are like the real show.
Pretty much.
One of the articles, they called it a sonic boom from a jet fighter,
Yeah, I saw that.
which is, pretty intense image.
Definitely paints a picture.
Could you break that down for us, though? Like, what does a shockwave on that scale actually look and act like?
So picture a ripple,
Yeah.
okay? Spreading out from where things hit, but instead of water, it's going through gas and dust, that stuff between stars.
Okay.
And these shock waves, they are really powerful.
Yeah.
Like they can heat gas clouds to millions of degrees.
Millions of degrees. Wow.
Hot enough to make new stars, basically.
So it's kind of like the shockwaves are like cosmic blacksmiths or something.
Yeah, like
forging new stars out of that gas.
Exactly.
It's wild.
Yeah, and what's even more kind of mind-blowing is that we're finding out that these shockwaves, they have like a dual personality.
Dual personality. Okay, now that's interesting.
Yeah.
Tell me more.
So when the shockwave hits cold gas, dense gas,
Okay.
it acts like that supersonic jet, breaking the sound barrier.
Okay.
Creates a sonic boom, tears through space,
Wow.
strips electrons off atoms,
Okay.
leaves behind this trail of glowing, superheated gas.
That's intense.
It's like a cosmic light show, yeah.
Okay, so that's what happens with cold gas. What about when it hits hot gas? Is it the same kind of like dramatic show?
With hot gas, it's a bit more subtle.
Oh.
Think of it like squeezing a balloon.
Yeah.
So the shock wave, it compresses the hot gas. Doesn't create the same flashy light show,
Okay.
but it still releases energy,
Okay.
but in the form of radio waves.
Oh, interesting.
So it's like the shock wave has 2 volumes,
Okay.
loud and bright for the cold gas,
Got it.
quieter, but still detectable for the hot gas.
So we're basically seeing all this cosmic drama because of some pretty awesome tech, right? The Weave telescope.
Oh, yeah, absolutely. WEAVE, which stands for, get this, William Herschel Telescope Enhanced Area Velocity Explorer.
Wow.
It's like our high-tech cosmic camera.
Nice.
It lets us see details in this collision that we couldn't before.
That's amazing.
It's really helping us unlock, the secrets of how galaxies evolve.
So this dual nature of the shockwave, that's a brand new discovery then, right?
You got it.
Thanks to Weave and, all these other amazing telescopes.
Yeah, they're all working together.
That's so cool.
Yeah, it's really challenging what we used to think about galactic collisions.
Yeah.
We're starting to see that they're even more complex than we first thought.
So much more going on
Yeah,
than meets the eye.
absolutely.
Okay, so we've got this galaxy crashing into a group of 4 others,
Right.
creating these awesome shock waves,
Yeah,
and they're triggering star formation on like a massive scale.
right.
Pretty epic stuff, but
Yeah.
what does it tell us about how galaxies evolve over time?
Well, you could almost think of Stephan's Quintet like a real-life cosmic laboratory.
Oh, okay.
By observing this galactic collision and the shockwaves it creates,
Right.
we're basically watching a time-lapse of the forces that have shaped galaxies for billions of years.
So like a front row seat to one of the most fundamental processes in the universe.
Exactly.
Wow.
And those shockwaves we talked about, they're not just creating those spectacular light shows. They're actually playing a critical role in how galaxies evolve.
Oh, okay.
They compress and heat gas clouds.
Right.
And that kickstarts the formation of new stars on a huge scale.
So those bright, colorful regions we see in images of Stephan's Quintet,
Yeah.
those are actually stellar nurseries.
Exactly. Those are stellar nurseries ignited by the collision.
Wow, that's pretty amazing that we can observe these processes happening millions of light years away.
Yeah.
But I have to ask, why should our listeners care about this?
Right.
What's going on in Stephan's Quintet? Seems so distant and far removed from our everyday lives.
That's a great question. And it's one that astronomers get asked all the time, you know.
Yeah.
It's easy to think about these events as irrelevant to us.
Yeah.
But the truth is, they're very connected to our very existence.
Okay, I'm intrigued. Tell me more.
Okay, so think about it this way. The elements that make up our bodies,
Okay.
the planet we live on, everything around us, it was all forged in the hearts of stars.
Right.
Every atom of carbon, oxygen, iron that we're made of,
Yeah.
it was created in a star that lived and died billions of years ago.
So we're learning about the origins of the universe and ourselves.
Exactly. Astronomy is all about uncovering the grand narrative of the cosmos.
Right.
And the more we learn about how galaxies evolve,
Yeah.
the more we understand our own place in the universe.
It's pretty amazing.
It really is a journey of discovery that connects us to something much bigger than ourselves.
You know, with WEAVE and all these other advanced telescopes,
Yeah.
it feels like we're entering a golden age of astronomical discovery.
Yeah, it's an exciting time.
What are you most excited about in terms of what we might learn in the future?
Oh, the possibilities are just mind-blowing.
Yeah.
We're not only going to be able to observe these cosmic events in more detail than ever before,
Right.
but we're going to be able to answer questions that we couldn't even imagine before.
What kind of questions? Give me some examples.
Okay, so for one, we might be able to directly image planets forming around other stars,
Oh, wow.
which would be a huge step in our understanding of how planetary systems evolve.
Right.
We might even be able to detect signs of life on other planets.
No, that would be incredible.
That would be one of the most profound discoveries in human history.
It feels like science fiction is becoming science fact.
In many ways, it is.
Yeah.
And the most exciting part is we're only just scratching the surface.
Right.
Every new discovery opens up a whole new realm of possibilities and mysteries to explore.
It's so true.
Who knows what we'll find next?
Well, we've covered a lot of ground today in our deep dive into galactic collisions.
Right, have.
Before we wrap things up, is there one key takeaway you want listeners to remember?
If I could leave you with one thought, it would be this. Never underestimate the power of curiosity.
I like that.
It's what drives us to explore, to discover, and to understand our place in this vast and awe-inspiring universe.
Excellent.
So keep looking up at the stars, keep asking questions, and never lose your sense of wonder.
You know, it's funny, as we've been talking about Stephan's Quintet
Yeah.
and these cosmic shockwaves, I keep thinking about how those shockwaves are creating new stars.
It really is amazing.
Yeah.
Makes you think about how everything's connected in the universe.
It does. It makes you wonder about the chain of events that led to our own solar system.
Oh, yeah.
If shockwaves from galactic collisions can trigger the birth of stars, could they also be responsible for the formation of planets and solar systems like ours?
That's a great question, and one that astronomers are still exploring. It's a fascinating one to consider.
It's just mind-boggling to think that the very same forces that are shaping galaxies millions of light years away might have played a role in creating our own little corner of the universe.
It really shows that we're all part of something much larger than ourselves.
Well, this has been an incredible journey through the heart of a galactic collision. For our listeners who want to see this cosmic dance for themselves, I highly recommend looking up images of Stephan's Quintet online. The colors, the shapes,
Oh, they're stunning.
the sheer scale of it all, it's truly breathtaking.
It's a good reminder that there's always more to learn and explore out there.
Well, on that note, we'll wrap up our deep dive for today.
Sounds good.
But keep those questions coming.
Yes.
Keep looking up at the stars and never stop exploring the wonders of the cosmos.
Absolutely.
Until next time, happy stargazing.